Hello, everyone. I guess we'll get started. My name is Alex. I'm an Android engineer at Lyft. I work on the design systems team there. So what that means is I basically just spend my time writing custom views and reusable widgets that are used throughout uh, Lyft. And today I'm going to talk about how we use custom lint checks to enforce consistent designs across the company. So I'm going to start by talking just so we're all on the same page about what lint actually is, give some examples of how we use lint, and then I'm going to end with a short demo showing how to create a very simple lint check. So before we begin, the slides are available at j.mp/lint slides, just so you don't have to take pictures during the talk. And all the source code is linked from these slides. So again, you don't have to worry about missing anything. So what is Lint? Lint is a static analysis tool, which means essentially it analyzes your code without running it and tries to find bugs in it. And even if you don't know it by this name, you probably do know what it is because it shows up in Android Studio as these little tooltips. So there are over 300 or so lint checks provided by Google that run automatically in Android Studio and show you helpful warnings like this. For example, if you're using an attribute that's supported in a newer API, it'll warn you that it isn't supported on older devices, or if you're using the wrong type of dimension for a text size. It runs in Java and Kotlin as well as XML, so if you forget to call super.onDetached from window, or even if you're allocating an expensive object in a method such as onDraw, it'll detect that and warn you about it so that you can catch the bug early. And one thing to note is that all of these lint checks that are run by default and provided by Google are very general. They apply to every Android developer, really. There's nothing too specific that runs, and that's where custom lint checks are really useful because you can use them to target issues that are really specific to your company. For example, if anything that you see in a code review could potentially, any bug or issue that you see in a code review could potentially be a custom lint check, right? And this is important from a design systems perspective because the rules that we want to enforce on our end might not apply to every company, right? And in many cases, we do want to be more opinionated. To give a few examples of what I mean by that, this is a subset of our color spectrum at Lyft. And in 99% of cases, we don't really expect people to venture outside of this color spectrum, right? We as Lyft have already kind of, we don't see many use cases for anything outside of what we provide here. And what we've done is we've created a custom lint check to sort of enforce that. So if you use a hard-coded hard-coded color in your layout XML, we'll detect that and point the developer towards the color spectrum instead. To take that kind of a step further, we also provide a set of elevation levels for people to use. So all of our buttons at Lyft use level 2 elevation level. Our toolbar is at level 4. Our navigation drawer and our sheets are at level 8. And to sort of enforce this, we've done something similar where if you use a hard-coded dimension, even if it's identical to the actual DP values that we specify in our set of elevation levels, we say don't use a hard-coded dimension, use our dimens that we provide publicly instead. So you're probably getting a general pattern here. This is a subset of our text appearance styles. We want every text view to look consistent across the entire Lyft app. So what we've done is we've created a lint check to point the developer in the right direction here. If they were to create a text size with 16 SP hard-coded in their layout, we would say, hey, use the closest available text appearance style that we provide instead. To sort of get an idea of what this looks like when we're talking about Java and Kotlin code, on the left, you probably recognize this as the standard Android toast widget, and there's nothing wrong with using this. But at Lyft, we have our own version of Toast um, that shows up at the top like this, and we want to use that instead. We don't want there to be a mix of Android toasts in one screen and LPL toasts in another screen. We just want to use one thing. And what we've done there is we've created a lint check that will detect usage of the actual Android toast class. So if you're a new developer coming into the company, you might not even realize that LPL toast exists, right? And by the way, when I forgot to mention this, LPL is the name of our internal design system. So sorry, I didn't mention that, but it's sort of similar to material design. We call it Lyft product language, LPL. But anyway, yeah, so if you're a new developer coming into the company, you might not even realize that this is a thing, right? So in this way, we use Lint not only to catch the bug, but to sort of educate people that maybe they should use this instead. To give one last example, we have a lint check that will actually detect usage of the word deprecated in resources. So we found about 1 or 2 years ago, we sort of rebranded the whole golden path of our app. But with that said, we couldn't migrate the entire app all at once. So what ended up happening was we had this brand new shiny design system, but we still had screens that were using these deprecated resources and icons and colors that we didn't want people to use, but people didn't necessarily know that they shouldn't use them. So we created a lint check that basically allowed us to just say, if the resource has the word deprecated in it, then you shouldn't use it. And this helped a lot with just copying and pasting of resources for new features. And again, just to emphasize, a lot of these lint checks aren't too complicated, right? Like they're mostly just sort of like detecting something that you shouldn't use and say, use this instead, right? It's certainly not at the level of complexity as something like detecting the number of allocations that you're making in OnDraw, like I showed before. But their impact has actually been like incredibly enormous because not only just for detecting bugs, but for the purpose of educating people about the rules of our design system. So, not everybody is going to know the rules that we want to enforce. Not everybody's going to read the documentation, and Lint has been a really great way of sort of, spreading that information across the company through, these helpful tooltips. So with that, I want to give a quick demo, just like a show of hands. How many people use custom lint checks at their company? Ah, cool. That's actually a lot. How many have written one before? Oh, cool. Around the same, maybe half as much. So I'm going to go through a live demo here, just sort of showing how simple it is to actually create these. And again, I don't expect, this is a lightning talk, I don't expect everybody to retain this information and be like, walk out of this room a Lint expert. But I kind of want to just show how easy it is to create like a very basic lint check. And again, all the source code will be provided at the end. So, you can refer to that after the talk. But let me just switch screens real quick. Oh, there it is. Okay, cool. Can everybody see that? Everybody read that? I can make it bigger. No, it's fine. Okay, cool. So one of the lint checks that I referred to earlier in this talk was that hard-coded hex color, and I want to basically just walk you through how to actually create that. So we have a sample layout here. It's using hard-coded hex color directly in the layout, and we want to detect this and say, don't use that, use some other color resource instead, right? So this is essentially like sort of the boilerplate code required to start off creating a lint check. Every lint check extends a class called a detector, and the detector in this case is a resource XML detector because I only care about scanning resource files. And each detector has a huge number of lifecycle methods that will be overriding in order to actually control the behavior of the lint check. So the first thing that I want to do here is I want to say only scan layout XML files, right? And in order to do that, I have this handy method called applies to. This is called each time before the lint check is actually run, and it passes me a folder type. And what I want to do is just to say return if the folder type is equal to resource folder type dot layout, right? So at this point, I have a lint check that will just scan all layout files in the app. The next thing that I want to do is I want to say, I want to detect attributes. I guess just to start off simple, detect attributes with the name background. So what I'm going to do is I'm going to override this next method called get applicable attributes. And what this allows me to do is it allows me to return a list of the attributes I care about. Just to start off simple, I'm going to just return a list of attributes, and it's just going to contain the word background. Finally, the last thing I have to do is I have to actually react to this attribute. And there's a lifecycle method that I can call visit attribute. And this lifecycle method is called each time lint encounters, in this case, an attribute with the name background in a layout file. And what I can do here is I can first check to see if well, actually, to explain a little bit about what's actually happening here. In this case, I have an attribute. An attribute is comprised of a namespace, a local name, and a value. In this case, I need to get that value. So what I can do is I can do attribute value equals attribute dot node value. So this will return the actual value of the attribute as a string. What I can do then is I can check if the attribute value starts with this little pound sign. If it starts with this, then that means it's a hard-coded hex color. And what I can do now is report the attribute using this context.report method. And I'm just going to say, don't use hex colors in layout files, right? And that's essentially all I need to do. I'm going to sync with Gradle just to make sure it works. And boom. So yeah, so it's pretty simple to just get something like this up and running. One thing that you're probably wondering is how do I actually get this to work with like all attributes, because this will obviously only work with background. If I do like Android text color equals this, it's not going to complain. And in order to do that, there's just this little constant that you have to know about ahead of time called XML scanner constants.all. And by returning this, it'll say, scan all attributes in layout files. And if I sync with Gradle, it should show up. Yeah. Well, you can't see it, but yeah. Cool. So one more example that I showed earlier in this talk is a lint check that prohibited usage of Android Toast, and I'm going to show how to do that in this example. So I'm no longer extending resource XML scanner. I'm just extending plain old detector and implementing the source code scanner interface. And what that allows me to do is it allows me to analyze essentially Java and Kotlin code. It says here that I'm only scanning Java code, but this is really just a way of saying to lint, scan Java and Kotlin, not only Java. So you'll find that the way to approach implementing this is pretty similar. You start off by just saying what method calls that you care about. And in this case, I want to get applicable method names, and I'm going to return a list of strings containing make text, and then I'm going to override visit method call. And this is called each time that lint encounters a call to a method called makeText in Java and Kotlin code. So there could be other method calls. There could be other methods called makeText. I need to somehow make sure that I'm not reporting false positives. And in order to do that, what I can do is I can use this evaluator variable on the context, and there's a method called isMemberInClass. You pass the method that's being called, and you say the fully qualified class name. So in this case, I want to check if the method is on a class called toast, and if it is, then I'm going to report that as a error and say don't use a toast. In our company, we'd say use an LPL toast instead, but at your company, you might say like use a snack bar, for example, right? And if I sync with Gradle, I should get an error here. Yeah. So those were just two very simple examples, and you might be wondering like, okay, how do I write more complicated lint checks? And that's a good question. But you know, one thing that we found is that these are the lint checks that are most useful anyways, just because, you know, as I mentioned earlier, just for the purpose of educating people about, you know, what rules we want to enforce. And, you know, even like pointing to documentation has been really helpful, just linking under this little more link. Like we have links to, you know, the LPL docs down here, and it's been really helpful for us. So let me just switch back to Keynote. Okay, cool. Okay, so everything I just did is at this link, j.mp/lint demo. Actually, everything I just did and more. There are actually like 5 more example lint checks down here. They sort of explore all the different possible ways that you can, you know, create custom lint checks. It also has details that aren't currently really being shown here about the project setup, what you actually have to do to get lint running in your project. But it's not too complicated. It's actually pretty simple. There are, here are some like really helpful links that you should definitely know about if you are interested in looking into lint further. The first one is the link that I just mentioned. There's a I/O talk, the second link that was given, I think, a year ago that gives a really good overview of what you can do with lint as well. The third one is the one that I would definitely most highly recommend you watch if you're interested in learning, you know, pretty much everything you need to know about lint. It's a super in-depth, like 40-minute talk given by Tor Norby from Google. He's the TL of Android Studio, and he explores pretty much everything that you need to know. And lastly, the actual lint. So there isn't actually much documentation about lint. The best way that I've found to actually learn about it is, you know, other than watching that talk that I just mentioned, is to actually read the source code for the Android Studio lint checks. And you can find that at j.mp/lint source code. And with that, I guess that's all I have. I guess, I don't know. I guess I can take questions if anybody has any. Or, yeah. So the question was, does it work outside of Android Studio and IntelliJ? And yeah, it does. Actually, the tooltip thing that I'm showing now is actually relatively new. Up until recently, I think they didn't even show up in Android Studio. That's like sort of a new thing. But for example, you can run all of this stuff from command line. And for example, we have it running automatically on CI from the command line. So that's how we primarily enforce it. Yeah. Yeah, so so the question was, how do you actually hook up the lint checks with Android Studio? I didn't show it in the demo, but you'll, if you look at the actual source code, it'll be obvious because there's a section about it in the README. Essentially, there's a registry that you have to create, and in that registry, you return like a list of the lint detectors that you want to actually be run. And then in your Gradle file, you there's a special line that you add to your Gradle file to like reference the registry, right? Yeah, yeah. So the question was, how do you enforce, like, instead of arbitrary hex colors, enforce some sort of like list of colors instead? I think it would be similar. It would just essentially be like I had a if statement or whatever that checked if the color resource began with a pound sign, right? And instead of that, I guess you would just add if the name is included in your like hard-coded list of colors that you want to provide, something like that. Yeah. Yeah. The question is, how much does it increase build time? So Lint, I think, so it is expensive sort of to run Lint, I found. But the I don't think it's actually coming from lint checks like these. Like the lint checks that are scanning XML are actually pretty cheap. It's the lint checks that are run in like multiple passes or doing complicated, you know, analyzing of Java code, like multi-threaded stuff. I think that's really where the main build performance issues would come. Oh, time? Yeah. I guess I am out of time, but yeah, if anybody else has any questions, I'll be here. Thanks.